Hey guys, we're continuing with 6.7, combining rational expressions with addition and subtraction. So our previous lesson we talked about multiplication and division. In this lesson we're going to talk about addition and subtraction. Objective is that students will be able to combine rational expressions with addition and subtraction. There are two guidelines for addition and subtraction of fractions. I know we all dislike fractions, but we're going to work through this together. Two guidelines. The first one says the fraction must have a common denominator, meaning the fraction that I'm going to add or subtract, they should have the common denominator. In other words, saying they should have the same denominator. Two, denominators can only be changed by multiplying the overall fraction by 1. And let's see what I mean. So exercise 1. Combine each of the following fraction by first finding a common denominator. Express your answer in simplest form. So 4x and 6x, those are not common. Of course not. So I want to know, what do the 4 and 6 have in common? So on the calculator, I can say GCD of 4, 6, and it will tell me 12. Now that means that my common denominator should be 12x because they both need to have an x in common. And I'm going to go ahead and ask myself, how do I get from 4 to 12? And in this case, you should tell me multiply by 3. Whatever I do to the top, I do to the bottom. And then you're going to say, how do I get from 6 to 12? 6 times 2 will give me 12. Whatever I do to the top, I do to the bottom. Now I'm going to go ahead and distribute this. It becomes 6x minus 15. I distribute. Then I want to distribute the 2 as well. 2 goes to 4 and 2 goes to 2. So 2 times 4 is 8x plus 4. Now that they have a common denominator, this is when I can combine like terms. So I know everything's going to be over 12. My like terms are my x's. So 6x plus 8x is 14x. And then what's minus 15 plus 4? That will give me negative 11. And this is my final answer. Now let's look at this one here. 5x and 10. We know that the GCD of 5 and 10, GCD of 5, 10 is 10. But notice that this one, it has an x. This one has an x. So I need to make this have an x as well. So to get from 10, what I'm going to do is multiply this by x and multiply the top by x. I know I'm going to make this 10x plus something over 10x. This is going to be times 2, and this is times 2. So now that I multiply everything by 2, because I want it to be 10x in the bottom, this is going to be 8x minus 2, and this is x squared plus 5x. Let's combine like terms. I know the bottom is going to be 10x. I only see 1x squared, so I'm going to write my x squared. What's 8x plus 5x? That is 13x. And then the minus 2, nothing has it in common. So this will be my final answer. Alrighty, moving on to C. So 3 over 4x plus 1 over 2x squared. So the first thing I need is a common denominator. So let's see what's the GCD of my numbers. 4 and 2 is actually 4. And then I always take the one that has the highest exponent, or if there's just one of them with an x, I will use that. So in this case, this is x to the first and x squared. So the higher exponent is what I'm going to use, which is x squared. So my new denominator should be 4x squared. Now I ask myself, how do I get from 4x to 4x squared? I need to multiply this by x. So the top becomes 3x, And then how do I get from 2x squared to 4x squared? I times it by 2. Then once they have a common denominator, I can combine like terms. In this case, there is none, so this becomes 3x plus 2 as my final answer. So it says each of the combination in exercise 1 should have been reasonably easy because each denominator was a monomial in nature, meaning there was one denominator, one term in each denominator. If it's not that easy, then what we need to do is to factor the denominator before trying to find a common denominator. So I need to factor and look for what they have in common and then try to make it the same. Okay? So let's go ahead and try some difficult ones here. So I want to factor this out. So the first one, I can see that the bottom has a 5 in common, so I'm going to take a 5 out. Y minus 3 plus 5 over, remember this is a square root, so I can write this as y minus 3 and y plus 3. Now that I have it factored, I want to know how can I make these equal? So this here, I see they both have a y minus 3. What is left out? The plus 3, and then there's a 5. So if I multiply this by 5, and then I multiply this side, I'll just write it here, by y plus 3, then what I'm going to do is now make this where the entire thing becomes 5y minus 3 and y plus 3. That's going to be my whole new numerator. I'm sorry, denominator. I'm in the bottom. So I need to figure out my numerator. Here in this case it was 4y plus 12, and in this case it's 25. Now that I have the same denominator, I write it back. And then in the top, my numerator, I am going to combine like terms. There's only one 4y. And then what's 12 plus 25? It's a positive 37. This is my final answer. So you need to factor, look for what they have in common. They both, and let's highlight it. Ooh, they both have this in common. And then I want to see this is left over on this side and this is left over. So what I'm going to do is take this on that side and then take the 5 on that side to make it even. Now let's look at B. So let's go ahead and factor. I can actually make a better line. And factor this out. The top stays the same. Now the bottom, with the bottom, that I can do my ABC method. My A, here, my A is 1, my B is negative 9, and my C is 20. Do your X method, you should get X minus 4 and X minus 5. Plus, 2 cannot be factored. And if I do the same thing, this is a quadratic, I factor that out as X minus 2 and X minus 4. Now I want to look at, they both have an X minus 4 and an X minus 4. But then what's left over, this is an X minus 5, which I'm going to take on this side. So I'm going to times this by X minus 5 and here by X minus 5. What's on this side is the X minus 2, which I'm going to multiply here. Let's just make this a little clearer. This is X minus 2. So again, this is what's left over on this side, and this is what's left over from this side. So this is where I am going ahead and take these over this side to make them equal, and then this 5 goes over here, and it comes up there as well. Now that I have all that craziness, I know my denominator here is going to be X minus 4, X minus 5, X minus 2. It doesn't matter it has that many, but what I'm going to do is that it has, both of these has to have the same denominator in order for me to combine them. This, if I use the box method, X, do the box method really quick here with x minus 3 and x minus 2. This is x squared minus 3x minus 2x plus a 6. So the top ended up being x squared minus 5x plus 6. And if I distribute, this is 2x plus minus 10. Remember, this is a 5. Sorry. Now let's combine. All of this gets one denominator, because that's my goal, to get one denominator. Then x squared is by itself. My x minus 5x plus 2x will give me a minus 3x and minus 4, since it's 6 minus 10. Now the last thing that I want to do is go ahead and factor this top part out. Remember, this is my a, my b, and my c. This is factored to x minus 4 and x plus 1 all over x minus 4, x minus 5, x minus 2. My x minus 4s can cancel, and I'm left with x plus 1 over x minus 5 and x minus 2. This is my final answer. Yes, I know this was a long one, but with addition and fractions, which we all hate, is that we have to get a common denominator. That's why I need to know what's left over and what can I multiply the other side by. Now let's go into some subtraction problems. So, subtraction of rational expression is especially challenging because errors that are naturally made when students forget to distribute that negative sign or the multiplication by that invisible 1. So let's try A. First thing, look at this. They have a common denominator, so this one's easy. I make it into one common denominator, which is x squared plus 4, and I combine my like terms. But I have to rewrite this as 3x plus 7 take away x plus 3. Now this is where the error is made. You have to distribute this negative sign. Remember that invisible 1 that's there? We have to distribute that. So this actually becomes 3x plus 7 minus x minus 3 over x squared minus 4. Then I'm going to simplify. This becomes 2x, because 3x take away 1x is 2x plus 4 over x squared minus 4. Now simplify, because it says express your answer in simplest form. So this becomes 2 is in common, x plus 2, and then the bottom can be simplified as x plus 2, x minus 2. The plus 2's cancel out, and I'm left with 2 over x minus 2 as my final answer. So this was especially easy because they had the same denominator. Now pause the video, make sure you're able to copy this so I can take this off. Great, you got a chance to copy. Now let's get rid of this because I need space for B. Now look at B. Does it have the same denominator? Of course it doesn't. So what I need to do is factor. Remember, just like what we did with addition, when it has different more than one term, I need to factor them to see what they have in common. So I'm going to come on this side for space sake. The bottom can be factored as, whoa, crazy line. The bottom can be factored as 2x minus 1 and 2x plus 1. Remember, if I take the square root of both of these, it's a difference of square. The top remains the same, and then this side is factored as 5 in common, so this becomes a 2x plus 1. The top stays the same. So just like what we did in addition, they both have a 2x plus 1. What's left over on this side? It's a 5. So we're going to take this 5 and multiply it on everything on this side. Then what's left over on this side? We have a 2x minus 1. So we're going to multiply by 2x minus 1 on the top and on the bottom. Then what am I left with? This becomes 5x minus 3 over 2x plus 1, 2x minus 1, and then the 5. Take away, distribute that 2 over, I am left with 4x minus 2 over 2x plus 1, 2x minus 1, and the 5. Now what I need to do is go ahead and let's move this down for a little. Combine like terms. I have one single big denominator, which is 2x plus 1, 2x minus 1. I'll just put the 5 in front. It doesn't matter. And I want to look at these. It becomes 5x minus 3, take away. And remember, because I'm subtracting, I have to put it in parentheses. This becomes 5x minus 3, take away 4x plus 2. Oh, this shouldn't be. Whoa. Be careful here. This is actually a 15. I did not distribute. See, you have to be extra careful. Look at me making mistakes. The 5 has to go to the x. The 5 has to go to the 3. So this is a 15. Sorry. See, we have to be extra careful. Even myself, I made a mistake there. Now all of this is over my same big denominator that I just had, and I want to simplify. This is a long question. Plus we have a Regents question at the bottom. So my last and final step is just to simplify this, combining my like terms. This becomes, yeah, what's 5x take away 4x? This becomes 1x by itself, and then this becomes what? Negative 15 plus 2 becomes negative 13, and everything goes over my crazy denominator, 2x plus 1, 2x minus 1. And this is my final answer simplified. Now take a breath, breathe that one in, take it in, and then we're going to work on C. Alrighty, here we go with C. Just bear with me. I know it's been a long video, but let's do this, work this out. So first thing I need to do is get a common denominator by factoring. X minus 2 and x plus 2 over x. Remember, this is a square root. Take away my a, my b, my c. This works out to be x plus 10 and x minus 2. Now I want to go ahead, look for what they don't. They both have a x minus 2, so now what's left over on this side is x plus 2, so I want to times this by x plus 2, and then x plus 10 is on this side, becomes x plus 10. Now that they have the same thing, I need to make one big denominator, x minus 2, x plus 2, x plus 10. What goes on top? X squared plus 10x. Take away x plus 10, x minus 2, and x plus 2. This becomes 6x plus 12. Now that we know this, we have one big denominator, and then this is a 10, x plus 10, the last one. We need to rewrite this, so it's x squared plus 10x, and then take away, and again, this is the biggest mistakes that is being made. I need to distribute the negative sign. So I have my entire denominator again. Whew, this is a long one. And then I have x squared plus 10x minus 6x minus 12. this can be simplified to x squared plus 4x minus 12 over x minus 2, x plus 2, x plus 10. Now the top, this is my A, my B, and my C. Factor this out, it gives me x plus 6 and x minus 2 all over my really crazy denominator. And then what can be canceled out? They both have a x minus 2, so that gives me my final answer, which I'm going to write over here as x plus 6 over x plus 10, which is left over, and x plus 2 as my final answer. The only thing with these ones, guys, I know it's a long video, but we're getting there. Remember, I want to show you every single step. With subtraction, you just have to make sure they have the common denominator. So, pause the video, make sure you have all of this copied down, because I'm going to delete it from the video to erase it so I can do the last question. I will challenge you to go ahead and pause the video and try this and see if we get the same answer. So make sure you have this copied down. Alrighty, so let's see what we got for D. So again, what I start off by doing is simplifying the denominator. X squared, remember this is my A, B, C. Simplified, I get x plus 1, x plus 4 broken down. I did the same for this side. This is my A, B, and C. I get x plus 4 and x plus. So as you can see here that they both have the x plus 4 in common. So I take the leftover, which is the x plus 1, and that's what I multiply both sides. On this case, the leftover is x plus 8, and I multiply that on both sides. Get my crazy denominator. This I use my box method. I get x minus 2 times x plus 8 gives me here x squared plus 6x minus 16, and here I just distributed my 8. Then I write it as one denominator because I can combine it since it's alike terms. I go ahead, remember I have to put this in parentheses, have to, and distribute my negative, leaving me with this crazy looking thing here. X squared plus 6x minus 16, take away 8x minus 8. Combining my like terms, I'm left with x squared minus 2x minus 24, and which can be simplified. My A, my B, and my C simplified to x minus 6 and x plus 4. The plus 4s are canceled, and then I'm left with on top is the, I could put it in parentheses, it doesn't matter, x minus 6. In the bottom it's x plus 8 and x plus 1. This is what regions look like. Which of the following is equivalent to this? So again, need to find my common denominator. So I am going to multiply. Let's rewrite this so I have some things to do. 1 over x. So I want to multiply this by x plus 1, not plus, x minus 1. And the top as well. Here I'm going to multiply by x. And what am I left with? The bottom becomes x minus 1, or you can write it out if you want to. It doesn't really matter. Here becomes x or 1x, and then here I'll distribute the 1, so it becomes x minus 1. Now that I have a common denominator, I can write this as x minus parentheses x minus 1. Remember, this has to be in a parentheses so we can distribute the negative sign, which gives me x minus x plus 1 over, you can write this as x squared minus x, it doesn't really matter. X minus x cancel, and I'm left with 1 over x squared minus x, and this looks to me like choice 3. Alright, so again, it's been a very, very long video. I want to thank you for your patience, and again, see me if you have any questions. Alright, good luck, guys.